Graphic statics is an extremely powerful method in building technology that enables you to design efficient and expressive structures like the master builders. The goals of this video are understanding the difference between form and force diagram, knowing how to label the spaces, transferring the lines from form diagram to force diagram, and learn the basic geometric dependence between form diagram and force diagram. This is the form diagram. It shows the geometry of a simple bridge. The lengths of all the lines represent the actual lengths of the single elements in the bridge. The idea of graphic statics is to find the forces in a system based on its geometry. This is the force diagram. The lines here have been transferred from the form diagram so that they are parallel to the original ones. Lengths of these lines do not represent the actual lengths of the elements in the bridge. Instead, they stand for the size and direction of the forces. If a line here is longer than another, it doesn't necessarily mean that the actual element in the bridge is longer, it just means that the force in this element is greater. This tutorial will be shown on these simple funicular systems. Every time you do an exercise in graphic statics, one of your first steps should be labeling the spaces. Look for the forces and imagine them as separators. The inside space is usually marked as O. Now label the other spaces in the clockwise direction. Remember to always label in the clockwise direction. You save yourself some confusion by drawing the force diagram. Now draw the load line. It must be parallel to the vertical force which it stands for. The size of our vertical force is 5 kilonewtons. The scale of our force diagram is 1 centimeter for 1 kilonewton, so the length of the loading line is going to be 5 centimeters. Now label the points on the load line starting with A. Remember, this works only if you have labeled your spaces in the clockwise direction. In the form diagram, this line runs between the spaces A and O. In the force diagram, it is going to run between the points A and O. Draw a parallel to it so that it goes through point A. Point O lies somewhere on this line. This line runs between the spaces B and O. So in the force diagram, it is going to be running between the points B and O. Somewhere on this line is point O, and where these two lines meet is point O. In order to find the forces in your system, you have to measure the lines in your force diagram. By transferring the numbers back into the form diagram, we can mark the forces in the system. Now we know that these two elements have a tension force of 5 kilonewton. If we were to dimension them, we would have to plug this value into the formula. In the second example, the overall height of this structure, a so-called structural depth, has been reduced. Let's see what happens with the forces. First, label the spaces. Draw the load line. The force is again 5 kilonewtons. Now label the points starting with A. Transfer the line running between spaces A and O into the force diagram so that it runs through the point A. Transfer the other line so that it runs through point B. Where the two lines meet is point O. Let's measure the forces. Transfer the forces back into the form diagram. Comparing the forces from this example with the forces from the previous example, we see that they have grown significantly. From that, we can conclude that the more structural depth you have, the smaller are the forces in your system. This is especially good to know if you have to design simple structures out of unreliable materials such as toothpicks, straws, or pasta. Now let's go to a slightly more complex example. Here we have two forces. The first one is 1.25 kilonewtons. The second one is 3.75 kilonewtons. Label the spaces. Draw the load line. Mark point A. Now draw the force AB. The size of the force AB is 3.75 kilonewtons, which makes it 3.75 centimeters. Draw force BC, its size is 1.25 kilonewtons. Now transfer all the lines just like in the previous examples. If you want to go further, check out the Equilibrium website. There are interactive examples that enable you to explore advanced graphic statics while having fun. These examples are made in GeoGebra. It's a free program that you can download and make your own. You can even use it in your design project. That's it. Have fun learning graphic statics and thank you for watching.